In this example, I'm going to go over an example of Gram-Schmidt orthonormalization in R2. So here's our example. We have a basis for R2 consisting of the vectors v1 and v2, where v1 is 3, 4, and v2 is 1, 0. And we want to create an orthonormal basis based on these two vectors. So the way that we start is by setting the first vector w1 equal to the first vector that we already have, v1, and then the second vector v2 will be v2, the second vector that we already have, minus the projection of v2 onto w1. So let's write out what that looks like in this case. So w1 is just going to be 3, 4 again, so I'll just write that down again. But w2 will be v2, which was 1, 0, minus, and then we've got to figure out the projection of v2 onto w1, so we take the inner product of v2, which is 1, 0, with w1, which is 3, 4, so that's going to be 3, and then the inner product of w1 with itself, so it's going to be 3 squared plus 4 squared, so 9 plus 16, so that's going to be 25, and then that's going to multiply the vector w1, which is 3, 4. So then let's calculate that difference. So we're going to have 1 minus 9/25, so that will give us 16 over 25, and then we're going to have 0 minus 12/25. So we'll have minus 12 over 25. So those two vectors will be orthogonal to one another because of the way that we've constructed them, but to go one more step we need to have them each be length 1, and to do that we need to divide by the length that they currently have. So next step is to figure out the length of w1. So that's going to be the square root of 3 squared plus 4 squared. So that's going to be the square root of 9 and 16. So that's the square root of 25. So that's going to be 5. So the length of vector w1 is 5. And then the length of vector w2 is going to be the square root of 16 over 25 squared and minus 12 over 25 squared. So what's that going to be? So let's see, we can put over a common factor. Well, actually let's pull out the 1 over 25 squared square root. We'll pull out a 1 over 25 outside, and then we'll have square root of 16 squared is 256, and 144 for 12 squared. So that's going to be 1 over 25 square root of, well, that's handy dandy, 400. So 1 over 25 times 20, and if we simplify that we've got a common factor of 5, so that's going to be 4/5. Okay, so now we can do the last step, and normalize vectors w1 and w2. So vector u1 is going to be 1/5 of 3, 4. Or if we write that out, pull the 1/5 inside, we'll have 3/5 and 4/5. That's going to be u1. And then for u2, we've got 1/4/5. So let's just simplify that to 5/4. And then we'll have 16/25 and minus 12/25. So if we simplify that, we're going to have 4/5 for the first coordinate, and let's see, minus 3/5 for the second coordinate. So those are our orthonormal vectors. They're orthogonal to one another and they have length 1.